Good afternoon. Today we are going to solve some problems which were asked in the university examination, that is SPPU, Pune University. Already in last video also mentioned, you can refer playlist, that is engineering mechanics. And in that playlist, you will come across a number of videos over there. So now we have problems that is from 16, 17, 18. Likewise, with the different university question papers. In first, we are with 3 problems, and 2 problems we will be with next video. Now determine reaction at A and B for the beam loaded and supported as shown in figure. Moments are at points C, D, and E. So we have this beam is given. So now we will have this beam. Support A, we have simple support. Support B, we have roller support. And we are interested to find reactions at A and B. So that is given beam. And now we are plotting, this is FBD of beam. So in FBD, we are going to replace support by appropriate reaction. So as A is simple, so we have 2 reactions. And B is roller, so we have 1 reaction. Now we will go more summation Fx equal to 0. So you can see as we do not have any load in X and Y direction. So in X direction, we are going to get HA that is equal to 0. We will go next moment about A0. Now we have first this moment which is anti-clockwise, so minus 10. Then we have this moment, this is plus 20, we have clockwise. And then we have this will be plus 40, again clockwise. And then we have due to RB, again anti-clockwise moment. So minus RB into 4. And we have that is equal to 0. We have not considered any distance with the moment because unit of this is already Newton meter. And therefore this already multiplied by distance, and then we got this value. So moment never been multiplied by the distance. And from this we will get RB into 4, and we will get this value that is equal to 50. And from this we will get RB that is equal to 12.5 kilonewton. So we have value of RB 12.5 kilonewton. Then we will apply Fy 0. So we have VA plus RB equal to 0 because we have these as moments, and Fy means we have forces in Y direction. And as we do not have force in Y direction, so we have only 2 reactions, VA plus RB. And from this we will get VA minus 12. Minus shows it is in downward. So whatever arrow you have considered at start, you have to round up it and you have to show correct direction. So we have value of VA 12.5 kilonewton, R downward, RB 12.5 kilonewton. So here you can say we have RA equal to VA equal to 12.5 kilonewton. That is reaction at A. Now this was asked in one examination. Determine the component of reaction at hinge A and tension in cable BC as shown in figure. So here we have only one support, that is support A, which is pin support. And then we have this will be pulley arrangement, that is rope and pulley arrangement. And we are going to hang this beam, that is with this system. So now we have, when we will cut this, then we are going to be tension, because we know in cable we have always tension, and we have tension, that means arrows are towards each other. So we are going to be like this. Now we have to take section from this, and then we have to draw the free body diagram for this. So in cable throughout we have tension. Means if I will draw this pulley separately, then we are going to get this pulley. We have this will be tension which will be downward, and again we have this will be tension on this side. And by using this, you can find the reactions which are at pulley. Now we will go for free body diagram. So we have this will be T at B, and arrow it will be away from the joint. And at C, we have again away from the joint. that will be T, and angle made by this, we have 30 degrees. So VA and HA will be the reaction, and angle I have already mentioned 30 degrees. Now we have total load actually over here, and this total load, we have load area of load diagram, 1/2 into 8 into 3. 1/2, we have base 3 meters, and height we have 8 kilonewton per meter. Actually, you can see here 8 kilonewton per meter, and it will act, that is at x by 3 or L by 3, and we will get it as 1/3 of 3. And then total distance from A, you will have this 3 meter plus this 3 cancel. Sorry, this 3 gets cancelled, and we will have this will be 1 meter. So now you can see this in next. We have this will be T cos 30 and T sin 30, and we have total load that will be 1/2 into 8 into 3. Now we will have this moment about A0, and taking moment about A0, we will have, due to this sin T sin 30, we have anti-clockwise moment. So minus T sin 30 into this 3 plus 3, 6. Then we have, due to this T also anti-clockwise. So we have minus T into 3. Then we have plus moment due to this. So already I mentioned, we have this distance, that is 1/3 of 3. So now we have, this will be values, then equal to 0. Then we have 60, because we have sin 31 by 2. So 1 by 2 into 6, this becomes 3t, and this 3t is 60, and this we will get 2 4s are, and this total we will get 4. So 4 4s are 16 into 3, 48, and from this we will get T equal to 8 kilonewtons. Now we will apply Fy0. So we have Va plus 8, because we have this T as 8 kilonewton, and this T becomes 4, that is 8, 1 by 2 into 8, and this becomes 4, because sin 30 we have 1 by 2. So plus 4 and minus 12, because we have 2 4s are 8 and 4 3s are 12. And from this we will get Va equal to 0 kilonewton. Now apply Fx0. So we have HA plus, sorry, this should be minus, because it is going towards left. So minus 8 cos 30, and that is equal to 0. And from this we will get HA equal to 6.93 kilonewton. And now we have this component. If you have to find out RA, then as VA 0, so we will get RA equal to HA as VA equal to 0. So when HA 0, VA equal to RA, and when HA 0, then we have VA equal to RA, and when VA 0, RA equal to HA. Then this was actually asked in one examination, that is analyze the beam loaded and supported as shown in figure. Now here you have to go first component of this 5 kilonewton. Now you can see we have, let us this angle theta. Then what we will get? We will have sin theta, that is equal to 4 by 3. I will show you by both, without considering value of angle and with considering angle value of angle. And cos theta, that will be equal to, sorry, 4 by 5, and cos theta will be 3 by 5. And if you will see this, then you will get this component as 5 into 3 by 5, and that is equal to 3, and then 4 by 5 into 5, and that is equal to 4. So now here I have solved by considering angle. So by considering tan inverse 4 by 3, you will get this angle as 53.13. I will first solve this by using angle, and then I will show you by direct value. So HAVA, then RB. This will be my free body diagram, that is FBT. Then we will take moment about A0. So we have 5 sin 53.13 into 2. And then we have minus RB into 4 plus 6 equal to 0. And we will get RB equal to 14 kilonewton. If we will take this 5 sin 53.43, this will be equal to 4, and then this will be equal to 3. Then we will get directly, that is 4 into 2 minus RB into 4 plus 6 equal to 0. And then also we will get 8 plus 6, 14. So RB into 4 equal to 14. In that case, angle need not require to find. Then we will have RB 3.5 kilonewton, Fy equal to 0, Va minus, actually we have cos, that is 5 cos 53.13, and we will get this value. Sorry, this is summation Fy 0. So we have Va upward, then 5 sin 53.43 minus 4 and plus Rb equal to 0. Rb we have 3.5, and from this we will get value of Va, that is 0.5 kilonewton. So Va we have 0.5 kilonewton, and Rb we have 3.5 kilonewton. Then we will apply summation Fx0. So we have Ha plus 5 cos 53.53. So this will be 53.13, and that is equal to 0. And from this we will get Ha minus 3. So that shows we have Ha will be 3 kilonewton, which will be towards left. So we have to round up this arrow, and we have to show correct direction. Ha equal to 3 kilonewton. Instead of this, you can directly write Ha plus 3 equal to 0, and we will get Ha minus 3 kilonewton. Now we can find reaction at A fast. I have to find Ra, which is equal to Ha square plus Va square. And from this we will get the root of 3 square plus 0.5 square. And from this we will get value that is equal to 3 square plus 0.5 square, root of this 3.04 kilonewton. Now we have to show the direction. So we have in this way. So this is 0.5 kilonewton. We have, this will be 3 kilonewton. And then we are going to get this value of Ra. Now, if we have to find this angle theta, then you can write it as 3.04 cos theta, and that is equal to 3. And from this you will get cos theta, that is equal to 3 divided by 3.04. Shift inverse cos, we will have 9.30. So from this theta we will get 9.30. And if we will find, this will be 0.986. Or you can have 3.04 sine theta equal to 0.5. And from this also we will get 0.5 upon 3.04 shift sine inverse. Also we will have 9.4. So little bit difference you will get over here for theta, because this decimals plays important role, as value of Va is very less. So likewise, we have to solve the problems related with engineering mechanics beams solved in university exam. Thank you.